This is recording now. 1 plus R over M raised to the mt. This is exponent. Nt is exponent. It's a multiplication. N and T. Ahora, who is M? Well, M is a compounding. That is the reason que es compound, interest compounding. Compounding, or M, ing, is the interpretation of the compounding is, you know, the money increasing like stairs, like that. But the period of the step of these stairs is a compounding. Is actually is the number of payment in 1 year. For example, to understand compounding, si es n equal 1, it's annually. Why annually? Because we have one payment or increasing your money one time in 1 year. See, n is equal to is semi-annually. What is the interpretation semi-annually? Que my money increasing, suppose que this is 1 year, this period is 1 year, 1, 2 years, and the money increasing 6 months, and after increasing 6 months. But each half of years, your money increase. Likewise, quarterly is 4. Quarterly is 4 times in 1 year. Monthly is each month is 12 times in 1 year. Weekly is 52 weekly in 1 year, and daily is 365 daily. Okay, entonces now the problem is specify what is the compounding. Okay, so you have several formulas. Okay, this is my first formula. Look, this is my first formula. Okay, this is for finding future value when you have in your hand present value. Important formula. Formula number 1. Formula number 2 is similar. It's the same formula, but sometimes you need to find the present value. So you isolate P, and the formula is A divided by 1 plus R over M raised to the nt. It's the same formula, but in this case, you find the present value because some problem, for example, you try to predict the money that you need now because you deposit this money in one bank account in order to get in the future some money. Okay, you see the problem like that. So sometimes you need present value, predict present value. Now you see if the compounding increasing, it's obvious que these stairs, bueno, is like that. Now the step is smaller, right? And si you suppose que es infinity, the curve is continuous. This is compounding when the n approaches to infinity. This is theoretical, I know. However, sometimes we have no idea. So you want to predict something, the compounding, because it's no bank account. It's supposed that I need to predict the price of the one stock market. So I have no idea. It's completely different idea. And you using continuous. Okay, what is mean continuous? Continuous is when the n approaches to infinity. And this is continuous. Continuous case. Okay? And the formula for the continuous is formula number 3 is future value. Is equal present value times e to the RT. It's a formula, so that part is reduced like E. And the number 4 formula is exactly the same for the present value. Present value is equal future value E to the minus RT because it's division. Okay, so you need to keep in mind that in finance, we're using these 4 formulas. Depending on the problem, okay, ready? We are ready to solve the first problem. The first problem. Let me erase everything and focus it in the first problem. Is this? Okay, make a zoom and read careful. Everyone, I suppose que bring calculator, no? Let me see. Calculator, please. Calculator, where is calculator? Here, over there. Oh no, here, over there. Yeah, this is my calculator. Look, this is my calculator. Yeah, let me put here. This is my calculator. Okay. Okay. The information that we have in the problem is if $10,000 is invested in account at 3% APR, compound quarterly. Okay, step by step. What is 10,000? No, 10,000 is the money I have right now. It's a present value. Okay. I deposit this money in the bank account. Okay, nice. The bank account offer this condition. It's 3%. So this is the interest rate, R, 3%. But 3% in the formula never we write in percentage. You write in decimal. And decimal is super easy. You divide by 100, the number is 0.03. Okay, it's 0.03 and the interest rate that I am using in the formula. Never in percentage, wrong. Compounded quarterly. Quarterly means that N is 4 times in 1 year. And will be an account in 5 years. So the time is 5 years. Okay. And what should I do? Well, I compute the future value. Future value, I don't know. So one more time, I using that formula. This formula is 10,000. Parenthesis, 1 plus 0.03 divided by 4, because N is 4, raised to the multiplication. So the exponent here is the multiplication NT. N is 4, T is 5, the exponent is 20. And that makes sense because you have 5 years and you split each year in 4 quarterly. In total, we have 20 period because it's a multiplication 5 year times 4 quarterly. So actually we have 20 quarterly, okay? Okay, now how you put in the calculator something like that? Well, this is the display of the hour calculator. Okay, this is the display of the hour calculator. I press on, clear the display. Okay, I encourage everyone follow me, try to follow me in your own calculator. And you put 10,000, 10,000. Multiplication. Open the parentheses because we have several applications inside. So inside you put 1 plus 0.03 divided by 4. Close the parentheses. Okay, I put here 1 plus 0.03 divided by 4. Close the parentheses. Power, because it's exponent. 20. Power 20. And press enter. Boom. Yeah, I get the answer. Who helped me with the answer? Come on. I get the answer.
11,611 plus.
Only one. 84. Okay. That means say $11,611
and 84 cents.
Exactly, because of the currency It's a money and you round to decimal place. Have no sense to talk about 3 decimal places. This is the finance. Beautiful. 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 Any question? You understand very well or no? Okay, we start doing financial problems. Compound interest. No problema.
No problem.
Okay, everyone follow me? Okay, so you follow me. Let's continue with the second problem. Next problem is a little bit more complicated, but it's no big deal. Okay, let me try. Okay, let me erase everything. Okay, let's download the new problem. Application loading me. This is the second problem. Wow, look. This problem say compound interest again. This problem say John wants to buy a 30,000 car. He has saved 27,000. Find the number of years it will take for his 27,000 to grow to 30,000 at 4% APR compounded quarterly. Okay, the idea is John needs 30,000, but John have in this moment in present 27,000. The plan of John is deposit his 27,000 in one bank account. Okay, this bank account have 4% APR and compounded quarterly. Entonces, the challenge is determine how long, so how many years he need to wait to complete the money, no? Maybe 5 years, 10 years, 2 years, 3 years, 4 years. Do you understand the idea? Yes or no? Answer me, please.
Yes.
Okay. So what is the information that we have? Who helped me to set up? We have a present value. Who is present value? P. Who is P? Who is P? Come on, the student can help me always. Anlan, David, Yasmin.
Present value is 27,000.
Absolutely perfect. That's the money que John have right now. Future value is also given or no?
30,000.
Exactly, it's the money that he needs, 30,000. What more information we have in my hand? Interest rate.
4%. 0.4.
Exactly.
Quarterly, which is 4 times a year.
Exactly, 4%. And never we are working in percentage. You have the formula, you put in decimal, no? So you divide by 100. And quarterly get 4. And what is my unknown? What is the thing I try to find in the formula? Time. I don't know the time, right? Okay. What is the formula I use? The same formula. Future value is equal present value 1 plus R divided by M 18. Plug it in the information that we have into the formula. Let me see. This is 30,000. This is 27,000. Parenthesis 1 plus 0.04 divided by 4. And the exponent, I don't know. I know partial. I guess N is 4, pero T is my unknown. Okay, so in this moment we have exponential equation because the unknown in my problem is located in the exponent part. But don't worry, it's easy. The first thing that you should do is divide both sides by 27,000. Okay, this is cancel out. This is the intention, and you cancel out 30 here. And divided by 3 is 10. And divided by 3 is 9. Or you put it in the calculator. And the calculator automatically reduce the lowest term for you. And the right hand side, I can see que we have 0.04 divided by 4. Es obvio que es 0.01, ¿no? And plus 1 is 1.01. Okay, you adding 0.01 raised to the 40. More clear now. This is my equation, my exponential equation. Es obvio que we cannot solve it by the traditional way. However, using logarithmic, of course, we can solve it. What kind of logarithm? Standard, no? Standard, maybe you solve it using LN or LOG, the logarithm you prefer. Okay, I prefer LN in my paper. Well, it doesn't matter. So we continue here. I apply logarithm on both sides. LN 10 over 9 is equal LN 1.01 raised to the 40. One more time, we apply the famous property number 7 that allow me move this exponent to the front as a factor. Logarithm of 10 over 9 is equal 40 natural logarithm of 1.01. Finally, divide both sides by 4 natural logarithm of 1.01. 1.01, this is point here. We have the expression can help me to compute the time. Divided by 4 ln 1.01. And this is time. This is the exact answer, but it's completely useless because I need, 2 years, 3 years, 4 years. No? So we compute the approximation. This is the idea. Guy, what is the reason that we need the calculator? No? We need the calculator because sometimes in the real life, we need no exact answer, that's horrible. We need the approximate answer, right? So in the display of the calculator, I encourage you try to follow me. I press, look, I put it on my calculator, I clear the previous example, I put LA, or LOG, whatever you want, LA, I select, you put 10, division 9, close the parentheses, 10, division 9, close the parentheses, I did the top part, divide by, get the bottom part, divided by. Be careful because in the denominator we have 2 guys, 4 and logarithm 1.2. So the mandatory need to open the parentheses because you put without parentheses, the calculator gets not smart. Try to following the operation from left to right and not obey all the operations from left to right. Okay. So you want to indicate exactly the order of operation that you need. You put a parenthesis, you put 4 multiplication, ln 1.01 and close 1 parenthesis for the logarithm and close another parenthesis to enclose everything in the denominator. 4 times ln
is equal to 64.
You're right. Let me finish. You are too fast. Presented and Lancet is
2.65 because you have to round it off. 7.
Okay, super. Or just 2.6 because remember we compute the time. Entonces I discover que es approximately a little bit more than 2.5 1 year. So basically, John need to wait 2 years or 3 years. And 3 years is enough. He have a little bit more money to buy the car. You understand? So depending on the application, you trunk it or you round off the number to the near whole number, to the near 2 decimal place, 3 decimal place, either way. Any question? Do you follow me? It's confusing, it's clear, this problem?
It's clear.
It's clear. Okay. Okay, entonces I want to erase the board. Let's move on to the number 3 problem. Number 3 problem is what's going on? There you go. Okay. Number 3 problem is about investment. Also, but in this case, is find the amount. So find the amount. All right, yeah. Find the future value that represents invest the present value of $2,000 at annual percent rate 8% compounded continuously. Wow. And for 1 year and 10 years. Okay. This problem illustrates that we're using another formulas. So we have 4 formulas for the compound interest. The 2 first formula is discrete problem, in which the money increasing like stairs, little by little. However, in this case, no. In this case, increasing continuously. Continuous is a curve, no stairs. Entonces, the formula is future value is equal present value time exponential RT. Esa formula. Present value is given is 2,000. Okay, the information is present value is 2,000. Interest rate is 0.08. And we have 2 conditional, 1 years and 10 years. Okay, so we need to repeat the computation 2 times, but it's the same formula. Entonces, 2,000 times E raised to the 0.08 times 1 is the first one. And the second is 2,000 times E to the 0.08 times 10. And I suppose that here in 10 years we have more money now. One, no? Okay, so I want to explain how in your calculator you find that. Okay, this is my calculator. Okay, and now I simulate the display of my calculator. So I clear everything. I put in the calculator 2,000 multiplication. Okay. What key I use? My key, I using the same key of the natural logarithm. This one. Look. But you press first, second. Because I need to using not the white function. I need to use the blue or the yellow, depending on the calculator. So I press second first, the same key. I can see in the display right now, E power parentheses. And inside the parentheses, I put 0.08 times 1 or times 10. Pero let's do it one by one. 0.0.
Okay. So I figured out both answers. So for 1 year, it'll equal $2,166.57.
Super.
And for 10 years, it'll equal $4,451.08.
Excellent. That's the answer exactly I have in my head. Boom. Any question? Any question? Are you get the same answer? It's important, guys. It's important. This is a moment, okay, I can help you so you don't know how you put in the calculator this, right? A ver, opinion. Everyone follow me? I know que Yasmin follow me. The rest. David, it's okay for you? Noel? Nicole? Frances?
I'm good, I follow. Thank you.
Okay. Kendry? Crespo? Sultanat? Kevin Betancourt? Víctor Villamizar? Juan Santana? Brian Durán? Roberto Alcalá? Sebastian? Gabriel?
I follow, Professor.
Okay, Alan, thank you so much. Okay, no big deal. We are doing well. Now, one more about compound interest. One more about compound interest. Okay, let's do it. Erase. Okay. Now, a PowerPoint. This one. Look at that. Okay, this problem talking about a bond. A bond is a document, a financial tool that you can buy in one moment in your life. And in some years, in this case, the maturity time of the bond is 10 years. And then you obtain more money, okay? You can buy in the government or you can buy in the company, government or company. Okay, so you are an investor and you are willing to pay some money because in the future, I need to get, I forgot to write here, que the money, okay, the maturity time and the maturity price, and this is $1,000. No? Okay, what means 1,000? 1,000 is the money I go back with me after the 10 years. Okay, 1,000 I received in 10 years, I received 1,000. So the challenge is, what is the price in the present value? So a bond can be redeeming in 10 years. How much should be willing to pay for it right now if you want to return? Well, okay, so we have two possibilities, no? Because when you negotiate the price, you have 7% compound monthly, okay. Or 6% compound continuously. So it's the interest rate, in this case, is 0.07, and the compounding is monthly, is 12. In this case, no. In this case, the interest rate is 0.06, and the compound is infinity because it's continuous. So you suppose que increasing, pero no like stairs, you know, like curve. It's another possibility. No? Entonces, okay, entonces basically my problem is compares two possibilities, and you need to determine what is the best option. Okay, because you have two options, number one and number two. Okay, this is similar to the test. In the test, we have one situation in which you have two options and you compute both and make a decision what's the best option. Then dependency of future or present value. In this case, it's obvious that the best option is when it's cheaper the present value, no? However, CS in the future value, the best option is when you take the greater return, no? So the bigger value, the greater value. Okay, so now, but in this problem we have a combination, two formulas, because we have present value, is the thing I try to find, present value is the price today, is equal future value, 1 plus R divided by M raised to the minus NT. Okay, this is a formula for the first, it's monthly. And the formula for the second, okay, continuous, is different, it's A e to the minus RT. Okay, let's do it one by one. I'm plugging in. Be careful, we're using the calculator again. I indicate you specifically the sequence of the key okay, you need to press. Okay, therefore I bring my calculator one more time. Okay, calculator here. Okay, calculator here. Let's do it in the first. The first is present value is equal future value, okay, is 1,000. 1 plus interest rate 0.07 monthly divided by 12 and raised to the minus multiplication and T. Well, T is 10 years and N is 12, so it's negative 120. Let me put in a calculator like that. And the calculator is, let me try to do simultaneous with you. Don't rush. Is 1,000 multiplication, parenthesis. Open the parenthesis, inside the parenthesis, you put 1 plus 0.07 divided by 12, close the parenthesis, 1 plus 0.07 divided by 12, close the parenthesis. Now power, symbol of the power. Now mandatory, you open the parenthesis. Why you open the parenthesis? Because it's negative form. Because if you don't put the parenthesis, the calculator don't understand it's subtraction of power. So you put to indicate it's negative 120. And be careful, because in our calculator, in every calculator, we have to not minus. We have the blue minus, okay, subtraction, and the white minus is negative sign, a negative value. So you press the Y, of course. You press negative 120 and close the parenthesis to indicate the finished text part. You follow me? Ready, pay attention. Boom, I press enter, I get the result. Come on, help me. What result you get?
$497.60 rounded out the because 59 with 6 rounded out to 60.
Very well. Jasmine say 497.596. It's obvious you round off to the nearest to the same to say 497.60. Boom, is the answer. This is the price. Are you willing to pay? You make a decision this. Let's see what happens when you select another option. We using the second formula, this formula. So using that formula, the present value for the bond is 1,000 again. Multiplication. Okay. Multiplication. E. So you put parentheses here minus 0.06 times 10. And the display of the calculator would be, let me see, 1000 multiplication again. You press the famous second and the same natural logarithm LM, but now it's actually exponential. Entonces, E power parenthesis. And inside you put minus, of course, minus Y color, white. Negative. Negative what? Negative 0.06. 0.06 time 10 years. Okay, and close the parenthesis.
That answer, you get $548.81.
Super, that's the answer. When you press enter, Jasmine say you get $548.81. Now the crucial moment in which you compare that price and that price. What is the best option in that case? Remember, this is the money that you spend right now. And your goal, when the bond is redeemed, you get 1,000. So what is the best business? Select this or select that? Select option 1 or select option 2? Using the common sense and imagination. Answer me, please. Help me to make a decision. How you get money in the life? Buy short and sell big, no? Entonces the best option is obvio que $497.60. Okay? It's clear. I was confused with that. Guys, are you there? Are you sleeping?
It's clear.
It's clear. Okay. Alan, it's okay?
Yes, it's clear.
Okay. Okay. Okay, so now let's move on to another application of the logarithmic and exponential equation. And no finance anymore, no compound interest.
Professor, before you move on, I had to let you know I have to go. I have a family emergency that just came up.
Okay. Are you leaving?
Yes.
Okay. I understand. Thank you for letting me know. Okay, let's move on to another science, maybe biology, maybe chemistry, maybe physics, and to see application for the equation that involves somehow exponential and logarithmic. Okay, let me try to see the next example. Okay, the next example is this one. Boom. Okay, it's about the exponential growth. Exponential growth of the population of the insect. Okay, so the microorganisms like a bacteria, virus, and maybe insect. The population increasing too fast, increasing exponential, right? So in this problem, talking about the certain insect populations growth according to the law of uninhibited growth. Okay, what's the reason? The reason is because this microorganism is no picky, only they need space and food, and that's it. And that the population of the human being not ever increasing exponential because the human being have competition, we have work. Now the microorganism only needs space and food. So now it's uninhibited growth. Entonces, what is the formula in this case? Well, the formula is easy. The formula is very, very similar to the compound interest because it's approximately the same idea. But a little bit, I changed something. The population at any time, that the amount of inset is equal P null, e to the, in this case, KT. Okay. The interpretation P null. What is P null? P null is the initial amount of insect we have in this experiment. Okay, in this case, 500. So the population to any time specifically in this problem is 500 e to the KT. And who is K? Well, K is similar to the interest rate, but this is not interest. This is the rate of change of the exponential. So it's a parameter that give me how fast or slow increasing our exponential. In this case, it's not given exactly directly, but we can determine that. Okay, so let me try to understand my problem so far. Okay, I highly recommend do one sketch to understand the word problem, because one image, in my opinion, is much better than 1,000 words. So for example, at the beginning, at t equals 0, we have 500. 500 what? 500 inset. The problem say in 10 days, suppose 10 days here, 10 days, 10, t equal 10. We have 611. 611. Okay, we have this point, and I need to find 20, 30, 1 more, 30 days. How many inset we have? Maybe like that. Because it's exponential, and exponential increasing too fast. Like that. Okay, so now we have, look, we have, this is the condition 0. I call condition 0 because that's at t equals 0. And this is condition 1. Okay, condition 1 help me to find the k value. Condition 1 help me to find the k value. It's not giving directly k, but I can find. And the condition 2 is the last condition. I know the time, 30 days, I need to find the population. So basically, the amount of insect that we have in 30 days is the final answer, no? Okay, so we have two answers. We have the partial answer, k, and we have the final answer, well, basically is population at 30 days. So in other words, the final answer is population at 30 days. Okay, let's do it step by step. Very important. And everyone using the calculator, and this is a little bit more long and complicated because we have two stages. Okay, calculate again. There you go. This is my calculator. All right, let me enlarge a little bit. It's okay. Okay. I copy again the formula. The formula says population to any time is equal to 500. Remember, 500 was the initial amount of the set, e to the kt. Now I using condition 1. Because condition 1, I have the full information. I have the time, que 10. I have the amount of insect, que 611. So when you plug it in the 10 days here, this is the population is 611, is equal 500, e to the k, I have no idea who is k, pero the t is 10, multiplication by 10. Okay? Okay, so in that moment, I have the exponential equation. And the only unknown that we have in this exponential equation is k. And this is my partial answer. Okay, so what should I do? Well, divide by 500 both sides. Yeah, 611 divided by 500 is equal e to the 10k. I want to put a number first because it's more elegant. Okay, now this is a crucial moment in which you have one exponential equation and you apply logarithm on both sides. But what kind of logarithm is most convenient to apply? In my opinion, is ln. Why? Because I know that property. ln e to the something is equal to something. Because ln and exponential have the same base and thus each other. According to the property number 4, remember property number 4 or number 3, I don't remember very well, is logarithm of the base a of the exponential is equal to x. In other words, it's like a logarithm and exponential undose each other. In this specific case, the base is e, thus the convenience logarithm that we apply is ln of this divided by 500 ln of this. Because I know very well that this is cancelled out, therefore magically happen that this is equal 10k. Wow, disappear that part and that part. Now final thing, case sorry, is natural logarithm 611 divided by 500 divided by 10 equal k. Okay, entonces this is a moment to use a calculator.
Equal 0.02.
Es 0.02. Pero let me explain in detail. Okay, look. You put in a calculator. ln parenthesis 611 divided by 500 close the parenthesis divided by 10, right? And you get exactly the same answer que Anlan say. Let me try because I want to write exactly what is the total answer. I don't copy in my paper, no. It's ln 611 divided by 500 close the parenthesis divided by 10. Okay, 0. Wow, it's almost 0.0200. For 8. A6. At least in my calculator, I get that. Okay. You can trunc it, you can round, or you can, I highly recommend do it that way. Pay attention, please. Remember, any calculator have available memory. And this is the partial answer. This is not the final answer. Because therefore, why no storage inside the calculator? So you press this key, look. STO. STO is storage. When you press STO key, at least in my calculator, you see the different memory that we have. A, B, C, D, E, and so on. I highlight A because it's the memory I am using. You select either. You can navigate for the arrow, select the memory you want. And so you press enter and you see in the display something like that. Look. Answer, arrow A. What means that? Okay, this answer, you now store in the memory A. Because I am using previously. So after. Okay, so now, see I have for A, and the calculator that I say this number. So I clear the display in U1, and we continue the problem. It's too long, sorry. This is called algebra. This is not negative algebra. And we come back again to the original problem, the original equation, SP to any time, S equal 500, E to the KT, But the difference now is que K I have inside the calculator, like A. And the A variable, I have K. Entonces ready to apply P at 30 days. Is 500 E to the A multiplication by 30. How you put in the calculator? How you put in the calculator? The calculator you put 500 multiplication E, remember E is second element key, you see something like that. And inside you need to retrieve the memory A. Therefore, how you are doing that? You press this, look here. The memory bar key. You press memory bar key. Okay, I saw the value of the A. You press enter. Entonces in my display, I can see something like that. A multiplication by 30. Multiplication by 30. And close the parentheses. Boom. You get some answer? Or no? Come on. Alan, David. Jasmine is not here.
It's clear.
No, but what is the answer? Alan. You don't get the answer. Okay, another possibility is you don't know very well the memory manipulation, you put that number here.
But if I calculate, it's only they only have E.
Oh, okay.
Oh, I put the number right there.
Guys, this is the moment to practice that. So okay, only working Yasmin, David, and Lan, and the rest. Follow me on. Or you are sleeping. Noel, Nicole, Frances, Henry, Sultanat, Kevin. Do you follow me on the calculator or no?
I'm following.
Exactly. Roberto Alcalá, 6. 912. Alcalá, 6. Look. The answer is 912.39, no? 0.4. Actually, remember, this is inset. We are compute the amount of inset. So you truncate or you truncate to the whole number, right? 912 inset. That's the final.
Can you have a question? So the E, you put the number 0.02 in, but like an A, it's still like you didn't have a number for an A. Or you also use that number 0.02?
Yeah. You can Alan. Look, you put it like that. Look, and you get approximately the same. You put 500 times exponential, and you put here 0.02 times 30. I suppose that you get the same answer or similar, no? Let me try by myself. 500 multiplication exponential 0.02 times 30.
Oh yes, I have
a little bit.
I can feel the
yeah,
things.
a little bit. I take 911.059, a little bit. That is the reason. Okay. Right? In the real life, when you solving the problem, suppose you are professional. You round, you truncate, and the final answer, never in the partial answer, because you truncate here, you make a mistake, and the mistake propagate in the computation. So you truncate, you using the memory, using the potential computation of your calculator. You store this partial information inside the calculator, and we, in the next step, we use the exact value. Well, not exact because nothing is exact, but at least the potential computation of your calculator. Clear or confusing? Come on, opinion.
I'm later now.
Exactly. Okay, sorry. I know that this is complicated and long. This is not my problem. But I try to do my best. You try to do your best. Okay, okay. So no problem. Everyone understand very well this problem of the biology? Okay, let me move on to the next application. The next application is the chemistry application. Chemistry application. Well, actually, it's chemistry, but it's also archaeology. It's the about application for the carbon-14 test. Let me explain what is a carbon 14 test. One of the tests is using in archaeology. Try to estimate the age of the antique object. And what is the idea behind carbon-14 test? Well, carbon-14 is a radioactive isotope. And this is disintegrates over the time. Okay, so this is the atom, and the atom disintegrates in different particles, and the amount of carbon-14 decreasing during the time. Look, one stage here can indicate decreasing. Entonces now, look, and this problem is exponential decay. It's exponential decay because the exponential is decreasing. And the formula is the same. Look, amount of substance to any time, no population is capital A, amount is A null, E to the K. But it's the same formula? No, not exactly, because in this case, K is negative. How do you know K is negative? Because it's decay. When it's decay, it's decreasing. And the exponential is decreasing. So now the problem says traces of burned wood along with ancient stone tools were found to certain approximate 1.67% of the original amount of carbon-14. So the concentration of the carbon-14 today in the present test is 1.67%. However, at the beginning, I suppose it's 100%. If the half-life of the carbon-14 is 5,600 years approximately, when was the tree cut and burned? Okay, let me explain it. What is the new concept? Half-life. What the hell is that? Half-life. It's easy to understand. At the beginning, okay, a lot of years ago, this is the time. This is time, but this time is now in years. And the other problem, the time was day, and this is years. At t equals 0, that's a long years ago, we have 100% of the carbon-14. And this decay exponential, decreasing. What is the definition of the half-life? Well, the definition is when the amount of substance is 1/2. 1/2 is 50%. 50% when this situation happens, this amount of year is 5,600 years. However, my problem say that the concentration for the carbon-14 is only 1.67%. Wow, it's very antique object. So my goal is try to find this time. Okay, I have no idea. One more time, we have three conditions on the problem. Condition 0, It's at the beginning. Condition 1 can always help me to find the k value. Okay, by the way, the k is negative because it's the k problem. And the condition 2 is the final answer. I have in my hand the concentration 1.67, but I need to find the time corresponding with this concentration. Do you understand the idea? Okay, so my equation is amount of substance to any time is equal 100. We're using relative unit and percentage, exponential KT. Okay, this is using the condition 0, 100. And some problem is express the amount of substance no in relative units, in gram. Suppose que is 50 grams, 25 grams. Okay, doesn't matter. Now, in the condition 1, it always help me to find the K value. We have 50%. It's 100 e to the K, is the thing I don't know. But I know the half-life of the carbon-14 is 5,600 years. We have in this moment one more time exponential equation, and the only unknown is K. Okay, let's do it. You divide by 100 both sides. Okay, so we get 50 divided by 100, 1/2. And we have in the right hand side e to the 5,600 exponent K. Okay, in this moment, one more time, I apply logarithm on both sides. It's obvious que we apply natural 1/2 equal, I don't need to repeat again. When you apply logarithm or something, is equal this, is the exponent, because this and this is cancelled out. It's a universal idea. Finally, K is natural logarithm of 1/2 divided by 5,600. This is my K. Just expecting to be negative value and very small value. But it's not important for me because I put in the memory of the calculator. Okay, I put in my calculator, my display. This is my display of the calculator for this example now. Hit copy. Putting on, clear display. You press LN key. 1/2, close the parenthesis. 1/2, close the parenthesis, divided by 5,600. 5,600. Bam. Yeah, I get super small number, negative, of course. It makes sense, but I don't need to copy. No. Don't waste the time, copy that. I copy for you. Can you see that? But no. Immediately, I put in a memory. What memory? The same memory, A, B, C. I select the same A. Why not? So I store, press the store key. I press enter. I press enter one more time. Okay, so I know. Okay, inside the memory A, we have the value of the K. Is this. In the second part of the problem, we come back to the original equation. Amount of substance to any time is equal 100 exponential KT. But I know in the condition 2, the concentration of carbon-14 is 1.67. Okay, and this is my new problem. And this new problem I solve for D, because I have K here. It's that value. So you divide by 100 both sides. Why not apply natural logarithm of 1.67 divided by 100? Yeah, I know that this is KT. Because logarithm and exponential cancels out. Therefore, T alone is divided by K, both sides, The natural logarithm of 1.67 divided by k is equal to. How you put this in the calculator? Well. You put in the calculator like that. Clear display. You put natural logarithm, ln. You put inside the parentheses 1.67 divided by 100. Close the parentheses. Divided by k. Pero k in our calculator is a. Because I storage in the memory a. Divided by a. So memory bar, I select a. A memory bar. And you press enter. Boom. I get the answer. Somebody get the answer? Somebody get the answer? No? Go ahead. In the chat. Activate the microphone. Bueno, the chat. A ver, the chat. Roberto Alcalá. Let me see in the chat, Roberto Alcalá. Roberto Alcalá. Say, guys. Yes, you're right. You're right. Roberto Alcalá, compute that. Roberto Alcalá is good on the calculator. Is 33,000 years, 62. Approximate years. That's the answer. Okay, too antique. Too very antique. Tools. Any question? Guys, it's important. Number one, understand the word problem. Number two, you will be able to manipulate the calculator, no? To solve the application for the logarithm of exponential. Important skill. Wow. Any question? No? Let me close the chat. Okay. Let's move on to the last problem. Let me erase the board. Okay, last problem is physics. It's a Newton law cooling. Newton law cooling. It's about, look at that. Don't be scared because in the test, I put similar example, no? No, there are infinity possibility of the application of the logarithm of the exponential. Okay, what about this Newton law cooling? Okay, suppose we have, look, after we read that, but I want to explain the formula and explain the idea behind this. Look, suppose we have a pizza Hut. Okay, this is the cheese. And we have pepperoni maybe. Here, it's a Pizza Hut. And the temperature of the pizza when you withdraw of the oven is 400 Fahrenheit degree. And immediately you put on the table, start the cooling process. So the temperature decreasing. So because the reason is because the heat is transferred to the environment. This is a room. And the room have, for example, 27 no. 7. Yes, because Fahrenheit degree. 27, 7 Fahrenheit degree. Fahrenheit degree. Okay, therefore, the tempers have initial tempers. I represent initial temper, and F represent the final tempers. If you are doing the graph of this phenomenon, you see something like that. This is the time again. But in this case, basically I say minutes because the process is faster. And it's temperature to any time. At T equals 0 is initial. And the initial is 400 Fahrenheit degree. Initial temperature, 400 Fahrenheit degree. And it's decreasing. But not decreasing to the decay, que approaches to 0. No, 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 no. Decreasing until get the final temperature, que is 70 Fahrenheit degree. Look. Okay, this is a little bit different process. And the equation is more complicated. The equation is temperature to any time is equal temperature final plus parenthesis temperature initial minus temperature final e to the kt. Okay, and k, well, k depending on a lot of things, but basically is similar to the decay exponential. Is negative because it's going down, it's decreasing, it's cooling. And depending, suppose to give me one condition 1 in the middle here, can help me to determine the k. Do you understand the idea of this is the most important formula for us now. In the PowerPoint, you see one, but I don't like this way. I don't like this formula. I like my formula. Is temperature to any time is equal temperature final plus temperature initial minus temperature final e to the k. Let's come back to the word problem. And let me read again careful and try to understand. An object is heated at 100 Celsius degree. Well, I suppose that this is initial temperature. Celsius degree. And then allow it to cool in the room whose air temperature is 30. This is the final temperature. If the temperature of the object is 80 Celsius degree after the 5 minutes, this is like a condition 1. So temperature at 5 minutes, remember T, little t is time, capital T is temperature, is 80, no? This is the condition 1. Okay, help me to find the K value. Okay, entonces the question is when will is temperature be 50? Okay, entonces I need condition 2. In the condition 2, I know the temperature is 50, but I don't know the time that corresponds with this. I have no idea this time. This is the thing I try to find. Okay, let me represent this in one graph because one picture is much better than 1,000 words. Look. This is my graph. This is time. This is temperature. In our specific problem, we start in 100 Celsius degree at T equals 0. Initial is T equals 0. This is 100. Temperature initial 100 Celsius degree. Temperature final is 30 degree. And this is a horizontal asymptote. And the temperature decreases by that. According to the Newton law of cooling. Okay. So I discovered experimentally that at T equals 5 minutes, look, 5 minutes, suppose que here, 5 minutes, the temperature is 80. 80. This is, I suppose, is condition 1. It help me to find the K value. This is condition 0. And the condition 2 is 50. I need to investigate 50 degrees. What time corresponds to this? I don't know. Condition 2. Do you think this sketch is clear to understand this? No, in my opinion, no, I respect opinions. But one sketch is easy to understand. Okay, so now let's move on. The first is set out the equation. The equation is a specific equation for our problem is temperature to any time is equal temperature final que 30 plus temperature initial que 100 minus 30 e to the KT. Okay, now 100 minus 30 is 70. So 30 plus 7 e to the KT. Okay, this is my formula specific for this problem. However, I need to find the K. For finding the K, we're using the condition 1. In the condition 1, I know that the temperature is 80, 30 plus 70 e to the K times 5 minutes. Look at that. Entonces I need to solve for K. Subtracting 80 minus 30 is equal 70 e to the 5K. I like to put the coefficient in the front, numerical coefficient, much better for me. It's a 50. Now divided by 70 both sides. So we cancel out that 0. Okay, ready to apply logarithm on both sides. LA. And you remember very well what's the reason. Okay, apply logarithm and cancel out the exponential at 5K. Therefore, K alone is natural logarithm of 5 over 7 divided by 5. I put in my calculator. It's doing. And my calculator look like that. And maybe Roberto Alcalá or Alan or David, help me, or another student. Go ahead. It's natural logarithm of 5 divided by 7 divided by 5.
Negative 0.067.
29. It's okay? Let me check it. Let me check. Divided by 5. Okay, you're right. 29, 4, another 4, 7. Okay. But I don't care. Okay, so in order to keep the accuracy of the problem, I store this answer in the memory, right? I press STO key. I select the memory A again. Bueno. Here I press enter. So I save this answer inside my calculator because I use it in the second part of the problem. In the second part of the problem, I come back again to the formula. What formula? That formula. I copy temperature to any time is equal 30 plus 70 e to the KT. But the only situation that I know very well is K, that I store in the memory A. Okay, I need to find the time, but the time que corresponde with the temperature 50. So this temperature now is 50. Is 50 degrees Celsius degree. Okay, my goal is find the T. So say 50 minus 30 is 20. Divided by 7 on both sides. Okay, I broken this because it's not equal. I don't put 7 here. So it's 2 over 7. Because cancel out that 0 is equal e to the kt. Okay, you apply logarithm both sides. Okay. I know that this is kt, but I need to find t because I have k. It's a natural logarithm of 2 over 7 divided by k. And this is the time. Okay, the time is always positive number because the time travels in the positive direction, never to go back. But k is negative. Entonces now, pero the problem is que natural logarithm of number less than 1. So when you put in a calculator, something like that, ln 2 over 7, this logarithm is negative. Divided by k, is also negative, divided by a negative positive. And this is the answer I'm waiting for. So natural logarithm of 2 over 7 divided by, in our memory, is 8. Memory bar, select 8, boom, I get the answer. Help me. What is the answer you get? Nobody? Nobody get answer? Come on, come on. Samuel?
9.678.
No, I don't like this answer. No 9, no 9. Something wrong. What is that? In the chat, somebody answered something. Yes, 18.6. Roberto Alcalá. 18.6. The answer is 18.6. 18.6 what? What is that? What is the thing I am looking for? What is the interpretation of 18.6? What is that? 18.6 what? Dollar. What is that? Let me see. Minute. Very well. Very well. Minute. 18.6 minutes is the time in which the temperature of the object is 50 Celsius degree. Okay, this is the time. It makes sense. This time, look at the picture. This is 18.6 minutes. Remember, it's 5 minutes in 8. This is a non-linear. This is exponential. Exponential is a curve that is non-linear. You don't expect a slope proportional. No, no, no. It's curve. It's a curve. Super good. Super good. Any question? Any question? Any question? You have trouble with the calculator in this last computation or no? Another possibility is you put in this number here directly. Okay? So you trunk it.
I will accidentally forgot to put log, natural log in.
Oh, okay. But you did after?
Yes, and I have the same answer.
Excellent. Any other question? Okay, so we start, and the time we have something about review package. Review package, you received the review package, right? I sent last time. Or no? No? Last time I sent to you review package. Tell me, yes or no? I sent the review packet or no?
Which packet, Professor?
My question was, I sent the review package or no? For the test 4.
I'm checking my email. 1 minute,
No,
Professor.
no, Professor.
No. The problem is I have different classes. So maybe I forgot if I sent this class or no. Don't worry. Don't worry. Don't worry. When the classes.
Professor, this is
No? Oh,
Professor,
yes.
this is
Yeah.
Laria. Just
Uh-huh.
wanted to know if you marked me present because this morning I couldn't hear, so I had to leave and come back. My internet was having problems.
Okay, no problem. I put present for you.
Thank you
Okay.
so much.
Uh-huh. My question was, I sent to
Professor, I
you.
don't see a review package for test 4 in the email.
No?
No.
Okay. Okay. So don't worry. I will send an email I sent today with the video. I send the review package. Okay?
Great. When is test 4 due? On December 10th?
I guess so. Yeah. December 10 is the due date for the test 4, and December 13 is the due date for the final. And in the story, I don't worry anymore. I grade, and that's it. I send the grade. Okay? Okay. Entonces
Thank
now
you.
we.
Have a good weekend.
Okay. Okay. Stop. It's too much for today. It's okay. It's okay. I appreciate so much your attention.
Oh, I'm
Listen,
sorry.
now-
I said goodbye a few minutes early. I didn't mean to cut the professor off. I thought it was 48. I apologize.